Hi everyone, I'm Ebenezer with FUTEK team, and today we're talking here directly from the engineering cave, as you guys can see. And I'm here with my friend Ali from electrical engineering department. And today we'll be talking about this new product. It's a new USB digital signal conditioner, USB225, and Ali is the design engineer. He spent hours and hours of research and development to create this new and novel product. And I have a couple of questions for you regarding this product, So when we engineers are developing new products or working on force measurement application, one of the most important or two most important factors for signal conditioning, it's the sampling rate, especially in a digital signal conditioning, right? It's the sampling rate and the resolution of the signal. So what can you tell me about this product?
So with the USB225, we've kept up with FUTEK's trend of having very high resolution, somewhat lower sampling rate devices with the standard version. And what we've been able to expand upon is the resolution. So we've gone down to 2.5 samples instead of 5 with the previous version, but we've also gone up to 20 bits noise free, which is pretty impressive for this device. We've also increased the sampling rate up to 38,400, which is also a big improvement from the 44,800 that we've had in the past.
Okay, understood. FUTEK product serves a variety of industries and a variety of different applications, right? So what type of high frequency with high dynamic application you can use as an example that will be a great fit for this type of high sampling rate and high resolution signal conditioner?
Sure. So one of the applications I would say that's a great fit for this would be a drop test, where if you have a high enough natural frequency sensor, the device could definitely measure that. And one of the big benefits of going up to 38,400 is being able to capture that high-speed data, but we've also been able to increase resolution at that sampling rate as well and get up to 12 bits noise free. So what makes this a good fit for that type of test is that not only can we capture the data, but we can actually capture it accurately versus some devices that may be able to capture it, but also capture noise at the same levels as well. So with the high resolution here, we're able to give actual good data back when you're running a test of that nature.
Understood. Now let's say, for example, a design engineer is working on a very critical application that the application requires that the signal conditioner is always working at 100% performance. What can you tell me about, for example, the fault detection or let's say health checks for the USB225?
Yeah, absolutely. So yeah, one of our big goals has always been to support more and more mission critical applications with our devices. And I think one great innovation here is that we've given this status LED here some more meaning. So typically this will be green if you're having a normal condition, or it'll be blinking red if you have fault detection. So the two types of detection that we have are onboard temperature, which we look at if the device itself is working within the operating range that we've spec'd it at. And we also have fault detection at the bridge, so we look at open and short circuits and let you know if something's going on with your sensor as well. Now the big benefit of that is, engineers all the time, they're collecting data, they're running multiple tests over the course of days or hours, and one of the worst feelings is when you go through that test and you realize something went wrong in the meantime and you have to restart.
Yeah, exactly.
With every sample that the device records, we're actually doing an error check and indicating here on this LED if something is going wrong. So as soon as something happens, if the board recovers, we'll go back to a recovered state. If it doesn't, it'll continue blinking red and letting the user know there's something wrong so that they can regroup, fix their setup, and run their test again and not waste time.
Okay, understood. And that's very important feature. Now you touch a very important point with temperature, right? So not all applications, the temperature, the ambient or the environment temperature is constant, right? Some applications, the temperature oscillates 50, 100, sometimes 1,000 Fahrenheit, right? And you mentioned about onboard temperature compensation, but how about, for example, sensors that is embedded with RTD or onboard temperature measurements? Is this compatible with this type of situation?
Absolutely.
Okay.
So a sensor like this LSB, where it has a single connector, we're plugging in here, it'll give you TEDS and RTD back. And I think the biggest benefit of having that RTD information is when you're looking at a system like this that you're explaining, where the sensor is further away from the electronics, we use the onboard temperature sensing to make sure that the electronics are working at the correct operating range. And then we use the RTD feedback to measure the temperature deltas that the sensor is going through. Since the measurement is ratiometric, you can use that temperature delta to then fix the output of the sensor as well.
Oh wow, okay, no, that's great. So just a quick summary here. So we have very important features. So high resolution, high sampling rates, onboard health checks and fault detections in real time, onboard temperature detection, compatibility with RTD equipped sensors. Now the million-dollar question. What can you tell me in terms of compatibility of this digital signal conditioner with FUTEK sensors, FUTEK products?
Yeah, so the device accepts millivolt per volt inputs, anywhere from 87.5 ohms to 5,000 ohms of bridge resistance. So 87.5 actually comes from if you take 4 350 ohm bridges and you connect them together, you get down to 87.5, and that's why we support that for averaging. And we also go up to 5,000, which is the limit that the FUTEK catalog goes to. Okay. So as long as you pick a sensor in the FUTEK catalog that supports millivolt per volt, this device will support it.
Which is the majority of FUTEK products, right? The force sensors, load cells, multi-axis sensor, and torque sensors, it's strain gauge based sensors. So
correct.
This signal conditioner here, this USB225 digital signal conditioner, it's compatible with, like say, almost the majority of the FUTEK catalog.
Absolutely.
All right. I noticed that that this product has two versions, the standard version and the Pro version. What are the differences and why you guys designed the two different versions?
So the standard version was more so meant to be a replacement for the original USB220 that we used to sell, and it supports similar sampling rates, but we've improved upon the noise-free resolution as we've gone up to 20 bits. The Pro gives you further features such as the RTD that we touched upon for temperature compensation, or TEDs. A sensor like this, as you're grabbing the cable, there's when you connect this guy gives you TEDs read back to this cable. Okay. There are also sensors that have the TEDs built into the cable here. So if you disconnect one sensor and you reconnect another one, the USB225 will automatically recognize it and calibrate itself to the TEDs information. The other change that we have here is the higher sampling rate. So for sensors that have higher natural frequency, or tests like drop tests and applications of that nature, we're able to support that with the Pro version.
Oh, perfect. Thank you. Thank you so much for your time. I think today we covered the most important features of this product. If you like this video, hit the like button and subscribe to FUTEK channel. Thank you.